Okay, greetings one and all, and welcome to, this has to be day number, Day number 2. Yes, day number 2, week 7, spring 2025. That's day number 2, week 7, spring 2025 of our journey together. And it's definitely a delight to have each and every one of you here for this evening's classes. Let's begin. So my name is Mr. Petit, and today is Tuesday the 18th of February, right? And it's 2025. The subject is, of course, mathematics. Make sure to write down what I have on the screen. Please make sure to write down what I have on the screen and make sure that you are paying attention. Today, we're going to be looking at average speed. Average speed. Okay. Average speed. Has anyone ever done average speed before in class, or, you know, at some point in your
No,
academic?
sir. First time
I've never
heard
heard that in my life.
Never heard of average speed?
Never heard of it either.
No?
I've had like a little bit.
A little bit? Okay. Yeah, average speed, right? So
That's why it was a video game.
in a video game, I mean, like in class. Have you done it in class? Like average speed? Don't worry, once we go over it, it's a very simple concept. So we're going to be looking at average speed. So first we're going to define what average speed is. So I'm going to give you the definition. Or like tell you what it's useful for, right? So I'm basically going to give you the formula first, right? So let's go ahead and look at the formula for average speed. So go ahead and resume slideshow. Okay, so write this down for me, please. There is a very useful and important triangle, right? That helps us to memorize the formulas for average speed, distance, and time. So there's an important triangle that helps us to memorize the formulas for average speed, distance, and time. And the triangle, I want you to draw this triangle with me. The triangle, and this is one of the ways, or I should say, this is the best way, in my opinion, to remember how to find the average speed. So draw this triangle for me, please. On the top here, we have distance, right? So on the top here, we have distance, right? Here we have speed, and here we have time. So I'm going to say the formula is shown below, right? So the speed distance triangle, is shown below, okay? The speed distance triangle is shown below. Let me minimize this, make this smaller, and increase that, put this up some more. All right. So this is how it works, basically. We say that when we're trying to find out what average speed, right? So speed is going to be distance, right? Distance divided by what? Divided by what? Y'all gotta help me. Speed is going to be distance divided by what?
Time.
Time. Very good. So speed is distance divided by time. Okay. And then, let me erase this. I erase all of it. Erase all ink. Time, right? Time is going to be what? Time is going to be, with highlighter. Time is going to be time is going to be what? Distance divided by what? Distance divided by what? Distance divided by speed. Very good. All right. All right. And then distance is going. Can someone tell me the formula for distance? Can someone tell me the formula for distance?
Speed times time.
Say it again. Speed.
Speed times time.
Very, very good. Speed multiplied by what? multiplied by
Time.
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 Very good.
Time.
So distance is going to be equal to speed times time. So those are our three formulas, and those are the formulas that we're going to be using to find average speed, the distance, and the time taken. Okay. So the first formula that I told you all was average speed. Okay. First formula is average speed. So let's put that here. It's going to be average speed is going to be the distance divided by time. So let's write that down there. So average speed is going to be distance divided by time. So Nakaria, what is the formula for average speed?
Distance divided by time.
Very good. Distance divided by time. Alea, what is the formula for average speed?
Distance times time.
Average speed, what's the formula for average speed?
Distance divided by time.
Very good. Dior, what is the formula for average speed? Dior, what is the formula for average?
By time.
Distance divided by time. Very good. And Condoleezza, what is the formula for average speed? Condoleezza, what is the formula for average speed? Kiana from Condoleezza. Christian Wilson, what is the formula for average speed?
Distance over time.
Very good. Distance divided by time. And we find that by using the same triangle, right? Where we see that distance is at the bottom, right? Time is at the bottom as well as distance is also on the top, all right? And so we could use this triangle to help us to determine the formula for the average speed. So all you have to do is remember the triangle. Remember where or what things are placed inside the triangle, right? So in our case, we're gonna have what? We're gonna have distance on the top, right? Divided by what? Divided by time. So distance divided by time is gonna be average speed, right? Average speed is gonna be distance divided by time, okay? Does that make sense? Let me know if that makes sense, please. Average speed
Yes, sir.
is
Yes, sir.
distance divided by time. So
Yes,
let's go ahead and
Yes, sir.
write the next formula. So the next formula, like we said that time taken, okay, time taken is going to be, what's the formula for time taken? That is what? What is the formula for time taken?
Distance divided by
Distance over
speed.
speed.
Distance divided by speed. Very good. So the formula for time taken, we're using the same formula. Time is going to be equal to distance divided by speed. So that's why the triangle is so cool, because the triangle, it helps us to get all of the formulas that we need. Okay. All right. That's why the triangle is so useful. Shalise, where's Shalise? Where's Shalise? Shalise, can you hear me?
Yes, sir.
You finished all the ones I sent you?
No, sir.
You're not finished with them?
No, sir.
Which one you are? You're doing it now?
Yes, sir.
Okay, good. Next we have okay, so that's so average speed is distance over time. Time is distance over speed. Okay, now the last formula that we have is going to be the formula for what? For
Distance.
for distance. What is distance? Distance is gonna be what? What is
Speed
distance?
times time.
Speed multiplied by time. Speed multiplied by time. Good. Speed multiplied by time. All right, inside the chat, I want everyone to put the formula for average speed. Inside the chat, put the formula for average speed. Is the chat open? Have I disabled?
It's disabled.
Disable?
It's disabled.
Okay, do it now. Inside the chat, put the formula for average speed. What is the formula we use for average speed? Average speed is what? Okay. Average speed is what? What is the formula for average speed? Average speed is gonna be equal to what?
Distance over time.
Put it inside the chat for me, please. Average speed is gonna be equal to what? Again, put inside the chat. All right, the answers are coming in. Okay, the answers are coming in. Very good. Average speed, y'all could say it now. Average speed is gonna be equal to
Distance time.
Distance over time.
distance divided by time. Very good. So in order for you to calculate the average speed, I have to give you the distance and the time. You divide them, and that's gonna give you the average speed. What's the formula for time? Time taken. The formula for time taken.
Distance divided by speed.
Time taken is gonna be what? Time taken is gonna be what?
Distance divided by speed.
Distance divided by speed.
divided by speed.
Very good. Distance divided by speed. And finally, the distance formula is gonna be what? The formula for distance.
Speed times time.
Speed times time. Speed times time. All right. What I want you to do is take a picture of this and send it to me via WhatsApp again. Take a picture of this and send it to me via WhatsApp. So I want you all to do right now. Take a picture of this and send it to me via WhatsApp.
Excuse me, Mr. B.
Go ahead.
I have to wait until my mother comes home. She has my phone.
Okay. Where is what's the name? What's the name? I need everyone to take a picture of their work and send it to me via WhatsApp. Aiden Adderley. Where's Aiden Adderley?
Hello.
Aiden Adderley, can you hear me?
Yes, sir.
Have you written down the notes?
Yes, sir.
You have to take a picture of it and send it to me via WhatsApp. All right. Understand me?
Yes, sir.
Alex Xavier. Where's Alex Xavier?
Yes, sir.
Alex Xavier. So, have you written this down? What I have on the screen?
Yes, sir. I written it down and sent it to you.
Okay, good. Good. And who all already sent in their work? Let me know, please, if you're already sending your work. Let me know if you're already sending your works. Okay. The rest of you, have you sent in your work?
Yes,
I done it right now.
Yes, sir.
Okay, good.
I have to
Um,
get a device to send the stuff. 1 minute.
Okay. Tayden Johnson, have you sent in your work? It's Tayden Johnson.
Just a second, sir.
And what's her name? Precious, have you sent in your notes yet?
Yes, I have.
Okay, good. All right, so what we're gonna do now, let's do a question on this, right? So we already know what is the like what are the formulas. So we're gonna work on doing a question based on these formulas, right? So we could actually figure out how to find the average speed, the time, and all that stuff. Okay, so let's go ahead and write these two questions down. So I'm gonna give you 2 examples, and then you're gonna work from there, right? So hopefully you all understand this. So there's gonna be examples. All right, so we have, it's gonna be number 1. So we say Sarah. Let's say Sarah is Sarah is a cyclist, right? And she cycles from the mall to her home. Okay, so say Sarah is a cyclist, and she cycles from the mall to her home in 2 hours. Okay, let me make sure this is a little bit lower. All right. I need to separate this so we could. I give you all two. Good. Let me make sure we thicken this. All right. We also know that the distance from our home to the mall is, let's say, 24 kilometers. So let's write that down. So the distance from the mall to our home is 24 kilometers. Let's say, how to say this? And our goal is to calculate the average speed. Okay, that's our goal. Go ahead, Antoine, read the question for me. Sarah's a cyclist.
Sarah is a cyclist. She cycles from the mall to her home in 2 hours. The distance from the mall to her home is 24 kilometers. Calculate her average speed.
Very good. So average speed, we already know how to do average speed, right? We know that average speed is going to be distance divided by time. Yeah, so let's write that down. The first thing we're gonna do, we're gonna write down our formula. So average speed is going to be distance divided by time. What is her distance? What is her distance?
12 kilometers per 12 per hour.
What is it? What is her
Is it
distance?
12 kilometers per hour?
I can't hear y'all. Y'all sound echoey.
12 kilometers per hour.
What is her? You giving me the distance or the final answer?
The final answer.
The final
Oh,
answer.
sorry.
Okay.
Is 24 kilometers.
The distance is 24 kilometers. Very good. What is the time? Time taken.
The time is 2 hours.
Very good. The time is 2 hours. So let's write that down. So the distance is 24 kilometers. The time is 2 hours. And so let's go ahead and make a note of that. So we have average speed is going to be distance, which is 24 kilometers, right? So 24 kilometers divided by 2 what?
Hours.
2 hours. And what is 24 divided by 2? That's going to be what?
12.
It's going to be 12. So the average speed, right, that she travels is going to be what? The average speed is going to be what?
12 kilometers per hour.
Very good. It's going to be 12 kilometers per hour. Go ahead, Amaya, and explain how we got 12 kilometers per hour for this answer.
First, we to find the speed, we divided the distance by the time, which is 24 kilometers divided by 2. And 24 divided by 2 is 12, and that gives us 12 kilometers per hour.
Very good. So it's very simple. All we need to do is find the distance traveled, find the time taken, and divide them two, and divide those two. And that's how we're gonna get our average speed. And make sure we put our units, 12 kilometers per hour. Do we understand how I got this? Let me know if y'all understand how I got this one so far. Let me know.
Yes, sir.
Let me know if y'all understand this.
Yes, sir.
Ziana Scron, can you hear me? Where's Ziana Scron?
Yes, sir.
1 second. Ziana, can you hear me? Where's Ziana Scron?
Yes, sir.
Explain how we got 12 kilometers per hour.
We divided distance over time, which is 24 divided by 2, which gives us 12 kilometers per hour.
Very good, 12 kilometers per hour. Very
Mr.
good.
Bateen, what is today's topic?
Average speed.
Okay, thank you.
It's not okay, Maya Leah. It's either yes or no. So let's go
Yes,
ahead.
sir.
So let's go ahead and do another question. That one is pretty simple. So let's say we have you were kind of low, Sashanik. Let's say that we have we could use right? Okay, so give me a male name.
Makai.
Makai,
Anthony.
Anthony,
Donald,
Donald,
George,
George,
Matthew.
Matthew. How about give me an R one? One allow it R.
Raymond.
Richard,
Let's just use Ryan. Let's just use Ryan.
Robert.
Ryan, you're all using these difficult ones. Ryan, let's go with Ryan. What does Ryan do? Sarah was a cyclist. What does Ryan do? Ryan is a what?
Ride a motorcycle.
he's fly plane. He's fly plane.
He's fly plane. What do you call people who fly planes?
The chauffeur.
Pilot, very good. So Ryan is a pilot, right? He flies. What he flies?
Your mind is part.
A
Pilot.
Charter plane.
private jet.
Fly like that. He flies a
A
private.
charter plane.
Let's go with, let's go with private jet. Private jet sounds better. Private jet from where?
India. Spain.
From Italy to Spain? Come on. From Bimini? Let's make it
To Hawaii.
let's make it from Bimini to Grand Bahama. The Grand Bahama. Yeah. And how long does it take? Let's just say that it takes 3 hours. It's just estimation, right? It shouldn't take that long, but the distance from Bimini to Grand Bahama is what? Let's say it's 135 miles. Calculate the average speed of the helicopter. I calculate the average speed of the helicopter. All right. Crimson, can you read this question for me?
Ryan is a pilot. Ryan is a pilot. He flies a private jet from Bimini to Grand Bahama in 3 hours. The distance from Bimini to Grand Bahama is 135 miles. Calculate the average speed of the helicopter.
Very good. Demi Haven, read the question for me, please. Demi Haven.
You could hear me?
I can hear you now.
Okay, Ryan is a pilot. He flies a private jet from Bimini to Grand Bahama in 3 hours. The distance from Bimini to Grand Bahama is 135 miles. Calculate the average speed of the jet.
Very good. Cavante Capron. Where's Cavante? Cavante Capron. Class, you have to respond to your name. If you're here, you have to respond to your name. Cavante, how do we answer this question?
Do the distance times the time. I mean, divided by the time.
Distance divided by the time. Very good. Okay, so if we're gonna do that, that means we have to say what? We have to use the formula, right? So the formula states that we have distance divided by time. Class, what is the distance from
135 miles.
Very good. The distance from Bimini to Grand Bahama is 135 miles. And the time is what? The time is what?
3 hours.
3 hours.
3 hours. Very good.
Oops.
All right. So the distance is 135 miles. The time is 100. No, the time is 3 hours. So we're gonna do, let's plug and chug. You're gonna say, by the way, what your answer is anyway? What you got for this?
45 kilometers.
45.
135 miles. Miles divided by what? 3 hours.
45.
45.
All right. So it's gonna be 135 divided by 3. What is 135 divided by 3? What you love? When you all divide it.
45.
45, 45. All right. Okay. So there's gonna be, so all you have to do is divide it. Okay. So we have to say 135 divided by 3. What y'all say y'all got again?
45.
45. 45.
I got
45 miles per hour. Okay. Yes.
We had a boom just now.
No. What is that?
I thought it was just
I don't know what it was either. I don't know.
I thought it was earthquake.
I felt nothing. I
I
don't know what these people are talking about.
I heard none. I heard none.
I see
Anyway,
the video just now. Say that's SpaceX doing whatever they doing over here though.
really?
Yeah, so
Oh wow.
I was watching that.
Elon Musk. Elon Musk. All right, 135. So 5 into 135. So we say, how many times does 3 go into 13? What's what? How many times does 3? How many times does 3 go into 13?
4 times.
4 times, very good. 3 times 4 is what?
12.
12, very good. And 13 minus 12 is going to be what?
1.
1. Bring down the
5.
5. How many times does 3 go into 15?
5 times.
5.
5 times. 3 times 5 is? 3 times 5 is what? 3 times 5 is what?
5 is 15.
15.
15, very good. Subtract, subtract. All right. And so the answer is definitely what? 45. So that's how we do a discard. So that's gonna be 45. But it's not kilometers per hour, right? It's not kilometers per hour. So we're gonna have, that'll be 45. 45, what? 45.
Miles.
Miles per?
Hour.
Hour.
Miles per hour. Very good. All right, so we're gonna say 45 miles per hour. And how do you write miles per hour?
MPH.
MPH.
MPH. All right, MPH. All right, question. Do we understand how to do these? Let me know if y'all understand how to do this.
Yes, sir.
Yes, sir.
Yes, sir.
All
Yes,
right.
I think so.
All right.
Yes.
So what I need y'all to do, take a picture of this and send it to me via WhatsApp again. Take a picture of it and send it to me via WhatsApp. Do that for me right now, please. Take a picture of your work and send it to me via WhatsApp. Again, take a picture of your work and send it to me via WhatsApp. Falea Miller, where's Falea Miller? Falea Miller.
Yes, sir.
Have you sent in your work?
I'm on it right now. My phone charging.
Okay. And Matthias Turnquest or Matthias Turnquest. Have you written this down as yet? Matthias. Matthias Turnquest. Where's Matthias? Matthias, can you hear me? Where's Matthias? I can't have from Matthias. Matthias, can you hear me? Matthias Turnquest. I can't hear from Matthias. Class, make sure if you are here, make sure that you're participating and you're engaged. All right. So when I call your name, you could be able to answer. All right. Okay. Debria DeVoe, can you hear me? Where's Debria?
Yes, sir.
Have you written this down as yet?
No, by right now, I'm still just trying.
Please quickly take a screenshot because I'm about to remove it. So.
Yeah.
Dior, have you sent in your work as yet, Dior? Again, Dior, have you sent in your work as yet? Okay. Dior, can you hear me? Where's Dior?
Yes, sir.
Do you understand how to do this?
Yes, sir.
All right. Have you sent in your work as yet?
No, sir.
What are you waiting on?
I have to wait until my mom come in.
Have you already written down the notes?
Yes, sir.
Okay, good. Danaj Moss. There's Danaj Moss.
Yes, sir.
Have you sent in the notes as yet?
I'm sending them in right now.
Okay, good. All right. Okay, so we have, let's go ahead. Move on. Okay, so what I'm gonna do, I want us to, let's move on to the grade exercise. Okay. So for the grade exercise, let's say that we have, oh, where are you gonna go? Let's go grade exercise number. So write this down for me, please. We're gonna do grade exercise. I don't want us to take forever on these, but okay, grade exercise. So write this down for me, please. We're gonna do a grade exercise. I want you to do this on your own.
Excuse me, Mr. Fatigue.
Go ahead. You have a
Can you
question?
go back for a second so I can take a screenshot of the last slide, please?
Okay, I'm going to go back to the previous slide. If you have not, if you don't have access to the first slide, please make sure that you do so. Take a screenshot of it before I move on back to this one. All right. Okay. That's this one. No, this one.
I get it. Thank you.
Got it? Okay, good. Okay, good.
I'm sending my notes now. I got a device.
Okay, perfect. So the first question, it's I'm only gonna give you all 3 questions. I think 3 is enough. We don't need 1,000. I just want you all to understand the concept and get some practice in. Durante Smith, please write down the question and answer it properly, please. Durante Smith, where's Durante?
Yes, sir. Yes, sir.
Read question 1, please.
Javen is a snowmobile driver. He traveled from the camp to the storage facility in the north in 4 hours. The distance from the fire camp and the storage facility is 36 kilometers and kilometers. Calculate the average speed of the snowmobile.
Very good. Trayvon Monco. Where's Trayvon Monco?
Good night.
Can you hear me?
Yes, sir.
You missed a very important part of class where we did the actual examples. So take a screenshot of this because this is the examples that we did before. Take a screenshot of this and quickly write this down so you can understand how to do it. All right, let me know when you're ready taking the screenshot or the picture. Okay, you got it, Trayvon?
Yes, sir.
Okay, good. All right, so go ahead, Kanan, read number 2.
A train travels a distance of 108 miles in 6 hours. Determine the train's average speed.
Very good. Toriko, read number 3.
A long distance runner travels 34 miles in 2 hours. Determine the average speed of this runner.
Very good. Determine average speed of this runner. Good. Destiny Johnson. I don't think our mic working. Rodrigo Rule, what number you on, Rodrigo?
Number 1.
Number 1. And Sasha Nick, what number you on?
Number 1.
Tanaya, do you understand what to do? Where's Tanaya? Tanaya, do you understand what to do?
Yes, sir.
And Samaya Walker, what number you on?
I'm a number 2.
Okay, that's good. Malaya DeVoe, what number you on?
I'm a number 1.
Number 1. Dior Borrows, where's Dior Borrows?
Yes, sir.
Have you sent in your notes as yet?
Yes, sir.
Where's the examples? You haven't sent the examples. So Dior, you need to send the examples. Do you understand what we did and what to do? Dior?
Yes, sir.
Okay, and Levantinique, where's Levantinique? Levantinique, have you sent in your workers yet? Levantinique. Yeah, Levantinique, you need to send in the notes and the exercises. You haven't done that as yet. Where's Levantinique? You need to send in your work and the exercise. Kylie Welchcombe, where's Kylie? Kylie Welchcombe. Kylie, can you hear me? If you're unable to speak, Kylie, type inside the chat because I can't hear you. Kylie, let me know if you can hear me, Kylie. And okay, so class, what number are we on? We are number what? What number y'all on now?
Number 2.
Number 2.
Number what? What number y'all on? Number 2? Number 2. All right. Rihanna, what number you on, Rihanna? Rihanna, can you hear me? Where's Rihanna? Kyla Welchcombe, can you hear me, Kyla? Kyla, can you hear me? Can't really hear from Kyla. Ronaldo, can you hear me? Where's Ronaldo?
Yes, sir.
What number you on?
Oh, I'm a number 2. Sorry.
Number 2. Do you understand what to do?
Yes, sir.
Kinda, what number you on?
I'm number 2.
Number 2. Okay. And Joel Sweeting, what number you on? Where's Joel Sweeting? Joel Sweeting. I can barely hear you. Speak into the mic. What number you on, Joel?
Number 2.
Number 2. And Alora Green, what number you on?
Number 2.
Number 2. Ariana, what number you on?
Number 2.
Tayden Johnson, can you hear me?
Yes, sir.
What number you on?
I'm on number 1.
On 1. Do you understand what to do for this?
Yes, sir. I send you the notes as well.
Where's your brothers? I haven't seen your brothers in class.
My little brother is having issues joining the class, and I'm not sure what my older brother is.
What do you mean you having issues? What do you mean by that?
He has tried to join for the from the past like 40 minutes. He said it to me as well. He doesn't know why he's having issues.
Doesn't know. So can he use your can you all share a device so you could participate in the class?
Oh, sure.
Yeah, y'all need to share a device.
Yes, sir.
So that you could see your screen.
Yes, sir.
Ethan Adderley. Where's Ethan Adderley? Ethan Adderley. Can you hear me, Ethan?
Yes, sir.
Ethan, what number you on?
I'm on number 2.
Number 2. Okay, good. Trayvon Monka, can you hear me?
Yes, sir.
Are you writing the notes from the previous slide?
Yes, sir.
Okay. Why you keep on coming in and out?
For some reason, they keep reconnecting.
Oh, okay, you having Wi-Fi issues. Is there anyone who's done with number 1? Is there anyone who's done with number 1? Let me know, please.
I finished all 3.
I'm done with number 1.
Finish.
I am.
I'm done
I
with
finished
all.
everything, so I'm
Who is completed with all 3? Let me know if you're completed with all 3.
I
Okay. All right. For those of you who are finished with all 3, what I need you to do is take a picture of your work and send it to me via WhatsApp. If you're finished with all 3, take a picture of your work and send it to me via WhatsApp. Please do that for me. Give me 1 second. 1 second, class. 1 second. All right, so let's go ahead and answer this question. Trayvon, I need you to read question number 1.
Javin is a snowmobile driver. He traveled from the fire camp to the storage facility in the north in 4 hours. The distance from the fire camp and the storage facility is 36 kilometers. Calculate the average speed of the snowmobile.
Very good. So based on class, he just arrived. Can y'all tell him what's the formula for average speed?
Distance divided by time.
Distance divided by time. Very good. Distance divided by time. So the average speed is going to be the distance of this object divided by time. So average speed is going to be equal to distance. What is the distance in this case? What is the distance?
36 kilometers.
36 kilometers. Very good. 36 kilometers. All over. What is the time?
4 hours.
4 hours. 4 hours. Okay, 4 hours. 4 hours. Let me make sure my handwriting is better than this. 4 hours. So the distance is going to be 36 kilometers all over the time, which is 4 hours. When we divide 36 by 4, what y'all get for number 1?
9 kilometers.
9 what?
Kilometers.
Kilometers flat.
Kilometers per hour.
Per kilometers per hour. Very good. How many persons got 9 kilometers per hour? Let me know, please, if you got 9 kilometers per hour.
I did.
Very good. Only 2 persons. The rest of you.
I did.
Did y'all get 9?
did.
Okay.
I did.
That's excellent. Okay, go ahead. Who wants to do number 2?
I could.
Go ahead, Nakaria. Read number 2.
A train travels a distance of 108 miles in 6 hours. Determine the train average speed.
So average speed, we know that average speed is going to be the distance divided by time.
Yes.
Okay,
So 108 miles divided by 6.
very good. 108 miles divided by what?
6 hours.
So 6 hours. So 6 hours. And this is 108
18 miles per hour.
miles. Go ahead, Nakaria. What you got for this one when you divided them?
I got 18 miles per hour.
Okay, so for number 2, the answer is 18 miles per hour. Did anyone else get 18 miles per hour? Let me know, please.
Yes, sir.
I got 18.
Okay.
Yes, sir.
Only 3 persons. The rest of you, did y'all get 18 miles per hour?
Yes, sir.
I got that.
Okay.
Yes, sir.
18 miles per hour. Adron, where's Adron? Adron, can you hear me?
Yeah,
Can you hear me, Adron?
yeah, so
How do we get 18 miles per hour?
you divide, um, 108 miles by 6 hours distance for overtime.
Okay, so your answer is gonna be what?
18 miles, 18.
8, very good, 18 miles per hour. Adron, where's your notes and your work? Have you sent them to me as yet?
That's what it's on. Still sending.
Say it again. Adron, I can't hear you. Have you sent in the work?
It's sending. It's sending. It's sending at the end. Sending. But it's
Yeah.
still sending.
Yeah, that's not true. You're telling me a lie. Take a picture of your work and send it to me via WhatsApp, please, because you never send in your work. Take a picture of your work and send it to me via WhatsApp. I don't understand why you're inside my class if you're not gonna send the work, Adron. You're not participating in the class and you don't want to send in the work. That's not gonna work. That's not gonna work. So you're wasting your parents' money. So Adron, take a picture of the work and send it to me via WhatsApp. And not only Adron, the rest of you take a picture of your work and send it to me via WhatsApp, please. Okay, now number 3. Any volunteers for number 3? Any volunteers for
Me.
number 3? Go ahead, Laura.
A long distance runner travels 34 miles in 2 hours. Determine the average speed of this runner.
Very good.
Average speed is distance. I know. Distance time over time, and the answer you will have to divide 2 into 34, which will give you 17. So that's your answer.
So we say 34 miles, right?
Yes, sir.
35 miles. All over what? All over
2
what?
hours.
All over 2 hours. Very good.
And your answer will be 17
And it's gonna
miles
be.
per hour.
So what?
17 miles per
Did
hour.
anyone else get 17 miles per hour?
I did.
Yeah, 17
Yes,
miles.
I did.
17 miles per hour.
I did.
Very good. I got 17 miles per hour as well. 3 out of 3. Anyone? Anyone got 3 out of 3? Let me know, please. 3 out of 3.
I did.
I
3 out of
got
3.
3 out of 3.
3 out
I
of 3.
did.
Did.
Excellent.
I got 3 out of 3.
3 out of 3. Excellent. If you understand how to do this, put I inside the chat again. If you understand how to do this, put I inside the chat. If you do not understand, put N. But if you do understand how to do this, put I inside the chat. But if you do not understand, please put N. All right. Again, if you do understand how to do this, put I. If you do not understand, put N inside the chat. That's for those who do not understand what's happening. Um, All right. All right, so let's move on. Let me see who all said I inside the chat. Very good. Okay, so that's how we do that one. So I think that one is straightforward. So average speed, all right, average speed. It was a formula for average speed. Average speed is going to be distance divided by time. And we use this triangle to help us. So the distance is here. Where are we gonna put the time? Anyone remember? Where are we gonna put time? On the
side.
on the top or here?
On the side.
On the side, very good. Where are we gonna put the, I'm sorry. We're gonna put
Supposed to be
the,
speed.
yeah, we're gonna put the, we put the speed right here. The distance is going to be on top. So speed is distance divided by time. Speed is distance divided by time. And that's how we do that right now. Okay. Like I said, take a picture of this and send it to me via WhatsApp. Okay, so let's move on from that. Okay. Let me start sharing again so that we can be able to do that. Okay. Okay. So the next one I want us to do is, let's go ahead and let's just say that we have this next example, and let's say if you're not speaking, please mute your mic. Again, if you're not speaking, please mute your mic for me. Let me put this here. So let's do some more examples quickly. All right, so let's say that we have examples, not grade exercise, examples. Write this down for me, please. Examples, more examples. Let's say that I'm gonna cut this in half. I only want to do 2 examples. So let's say that number 3, put this on the side. Let's say that go ahead, Antoine, read this question for me.
I can't see none on your screen. Only thing it says example.
Can you see it now?
Yes, I can see it now.
Go ahead.
That's a Lila.
Yes.
Lila travels using a local train. The train travels from Spain to Italy with an average speed of 50 miles per hour. Her commute takes 2 hours. Determine the distance she traveled.
Very good. Determine the distance that she traveled. Okay, determine the difference. 1 second. Let me start sharing again because I think I'm sharing the wrong screen.
Now I regret using ink.
No, it is the right screen. It's just the wrong. Okay, we good now. Go ahead, Antoine, read it again.
Lila travels using the local, hold on. Why it's zooming? Oh, no. Using the local train. The train travels from Spain to Italy with an average speed of 50 miles per hour. Her commute takes 2 hours. Determine the distance she traveled.
Very good. Write this down for me, please. Again, write this down for me, please. Aiden Deal. Where's Aiden Deal? Aiden Deal. Aiden Deal, can you hear me?
Oh, my mic was muted. Yes, sir.
Okay, yes. So Aiden, read the question for me, please.
Okay. Lilia travels using the local train. The train travels from Spain to Italy with an average speed of 50 miles per hour. What does that say? Her commute takes
Mm-hmm.
Her commute takes 2 hours. Determine the distance she traveled.
Very good. And Destiny Taylor, read number 3, please.
Lila travels using the local train. The train travels from Spain to Italy with
Italy.
an average speed of 50 miles an hour. Her commute takes 2 hours to determine the distance she traveled.
Very good. Determine the distance that she traveled. Okay, so class, what is the formula for the distance traveled? Anyone can remember? What's the formula for the distance
Are
traveled?
you supposed to multiply the time times speed?
Speed times speed multiply.
times time.
Very good. Speed multiplies by time. And the way that we remember the formula is we just gotta drop the triangle. I can't tell you how many times inside my exam I had to draw this triangle. Because I wasn't remembering no formula. I just remember the triangle, and the triangle tell me everything. So I remember I put the S there, the D there, and the T here. So we know that that means that the distance is gonna be what? The speed multiplied by what? By the time. You put your finger over the D, and it's gonna be what? This the speed multiplied by time. Okay, so if that's speed multiplied by time, what is the speed in this case? What is the speed in this case? The speed is
50
what?
miles per hour.
The speed is what?
50 miles per hour.
50 miles per hour.
50 miles per hour.
And what's the time?
2 hours.
The
2
time is 2
hours.
hours. Very good. So based on that, what's going to be the distance?
25 miles per hour.
No, remember we're multiplying.
100.
We're multiplying.
I thought it's dividing.
No, distance is speed multiplied by time. Trayvon. Okay? Don't make this hard. Math is easy. Don't make it hard. So there's nothing hard about this. So what's the distance going to be?
100 miles.
100 miles.
100
Not miles
miles per
per hour. Not miles per hour. It's just distance, right? It's just going to be 100 what? 100? 100?
100 miles.
100 miles. Very good. 100 miles. And so what we have here is we have, let's go ahead and multiply. We have, the speed is 50. So it's going to be 50, right? Multiplied by 2.
Excuse me, Mr. Petit.
Yes.
In the event that you had said that it took her a week, would we have to change that to hours?
That's correct. Very good point. So if they give you it in a different unit, you have to convert it into the hours or whatever units they ask the question to be in. All right. All right. Do we understand how I got 100 miles? Let me know if y'all understand how I got 100 miles, please.
Yes, sir.
Yeah.
Yes, sir.
Good.
Yes, sir.
Yes, sir.
Yes, sir.
Caleb, how do I get 100 miles for this? Caleb Conliffe.
You multiplied the speed and the time.
Very good.
Mr. Pete, I have a question. So, right, my phone was lagging, so I didn't know if you talked about this. But time, that means time is neither multiplied or divided, dividing distance by speed, right?
Say it again.
That means that time is neither multiplying or dividing distance by speed.
Why you say neither? So if we,
because I don't know which one. I don't know which one. Because I
okay,
was lagging it and stuff.
okay, so if we have the formula, right? We say speed is equal to distance over time, right?
Excuse
Speed.
me, Mr. Bitty.
Yes.
May I use the bathroom, please?
Yes, we can. So speed is going to be distance over time, and time, right, it's going to be distance over speed. Okay, that makes sense. You understand what I'm saying, Aiden?
Yes, sir.
So speed is distance over time, and time is distance over speed. And distance is speed times time. All right, you understand what I'm saying or no?
I think I understand what you're saying.
So in each case, right? No. Great. Keep. In each case, you cover each letter. So for example, if we trying to find, let me use a box. So if you're trying to find the distance, you cover D, and the distance is gonna be speed times time. So just like how we have this. If you're trying to find time, cover T. Time is gonna be what? Distance divided by what?
Speed.
By speed. And if you're trying to find speed, speed is gonna be what? Distance divided by
time.
By time. Does that make sense? Does that make sense? Aiden?
Yes, sir.
Okay, good. So let's go ahead and do another question. Class, do we understand how we got 100 miles?
Yes,
In the
sir.
in the formula?
Yes, sir.
Yes, sir.
Good. Okay, so let me move this. And okay, good. Let's do another question. So let's say we have Sabria travels, say she travels using Delta Airlines. I don't know if we want to use Delta Airlines because, you know, given all
They
that
slow.
So what happened?
they slow. That's the least of your worries. Let's use
You ain't get
Bahamas.
on the plane.
Let's use
Some
Bahamas Air.
reasonably playing crash.
Let's use Bahamas Air.
JetBlue.
JetBlue, please.
Yeah, JetBlue.
Say JetBlue.
American Airlines.
All right.
Bahamas.
We're gonna use Bahamas Air
Air.
because Bahamas Air has never crashed ever. Never had a.
Yes.
Nope. Bahamas Air has never crashed. Nope. Never crashed.
They run that.
No, Bahamas Air has never crashed. Look at their history. They've never crashed before.
They planes leave dead late though.
I've never encountered any lateness with Bahamas Air. Bahamas Air is a sponsor of this class. I'm gonna just kidding. All right, Alex Delaveau, go ahead and read number 4. Alex Delaveau, read.
It gotta be the sponsor because you say no lateness for Bahamas Air. My God.
Go ahead, Alex Delaveau. Go ahead, Alex Delaveau. Go ahead, Delaveau. I can't hear from Alex. So, Makaya Roca, read the question, please.
Sabria travels using Bahamas Air. Her journey from Nassau to Texas takes 3 hours. The airplane is moving at an average speed of 121 kilometers per hour. Determine the distance between these destinations.
Very good. And Carlita, read the question for me, please.
Sabria travels using Bahama Air. Her journey from Nassau to Texas takes 3 hours. The airplane is moving at an average speed of 121 kilometers per hour. Determine the distance between these destinations.
Very good. Okay, so what is the formula for distance, class? What is the formula for distance? Anyone can answer. What do you say?
Speed times time.
Speed times time.
Speed multiplied by time. Very good. So, okay. What is the distance?
I have a question.
Sorry, what is the speed? 1 second. What is the speed? What is the speed in this question?
121 kilometers.
121 kilometers per
Very
hour.
good. 121 kilometers per hour. Go ahead, Joel.
I just got asked, what was the difference? Like, how would you know the difference between like speed and time? Is it like how the number? is like written.
That's a good question. Oh, that's a good question. I haven't even thought about that. How do we know which one is time? How do we know which one is speed? Right? Anyone want to help him with that?
Time has HRS on the side.
The wording.
Very good. So time has the hours behind it, but speed is a rate, right? Speed is also a ratio, right? It tells you what happens for every, right? So for every 1 hour, 121 kilometers has passed, right? So you're gonna see it written as like a ratio of two quantities, whereas time is just hours, or they might say days or something like that, or minutes, but you always want to make sure it's in hours, okay? Unless they tell you otherwise. So let's multiply these two. When we multiply them, we have what?
363.
363, that's what you got?
Yes, sir.
Yes,
Okay.
sir.
Yes, sir.
So 100, y'all locking that answer in?
Yes, sir.
Yes, sir.
Yes,
Sure.
sir.
Sure.
Yes, sir.
Okay. 3 times 1 is what?
3.
3. 3 times 2 is what?
6.
6. 3 times 1 is?
3.
3. Very good. So that means that it's actually what?
363.
363.
Very good. Exactly like y'all said.
Miles.
Miles. Very good. Miles. 363 miles.
Yeah, I was right.
Okay. So that means that you all was right. So let's go ahead and let me put this here. So distance is going to be equal to distance is going to be equal to the distance here. Distance is going to be, oh, not 100, 363 miles. All right. Okay. Dexter Hannah, can you hear me?
I have a question.
1 second. Dexter Hannah, can you hear me? Dexter Hannah, can you hear me? Okay. Dexter, have you sent in the notes as yet? Was it sent in the notes? Elkanique Lloyd, can you hear me? Have you written this down as yet?
I still writing it down.
So writing it down.
Okay.
Empress, where's Empress?
Yes, sir.
Can you read and explain how I got 363? Start from the question. Sabria travels.
Sabria travels using Bahama Air. Her journey from Nassau to Texas takes 3 hours. The airplane is moving at an average speed of 121 kilometers per hour, right? Determine the distance. Determine the distance between these destinations. Distance equals speed times time. Distance. I don't have to read all that, right? Or do I?
Just explain what we're doing.
Okay.
What did we do to get 363?
I'm back, Mr. But
1 second, Mr. B.
Okay, I don't think she was paying attention.
I am, but my screen just went out. Hold on.
Okay.
Why?
Okay, let me ask Travanti. Travanti, can you hear me? Travanti, can you hear me? Can you hear me, Travanti?
Yes, sir.
Explain how I got 363.
You divide 121.
I divided.
I mean, take away it, multiply it.
I take away? How did I get 363?
Oh, you
Multiplied.
Can I answer, Mr. Petit?
Travanti is answering. What happened, y'all? Let him answer.
You multiply 121 kilograms multiplied by 3 hours
Uh-huh.
and
Again.
get 363.
3 what?
63.
Good. So we say 3 times 1, which gives us 3. 3 times 2, which gives us 6. And 3 times 1, which gives us 3. All right, are we done with writing this? If you're done, take a picture of your work and send it to me via WhatsApp. Again, take a picture of your work and send it to me via WhatsApp.
1 second, I'll finish writing number 4.
Okay. Again, take a picture of your work and send it to me via WhatsApp.
Did I ask me a question now?
Yes, go ahead and ask the question.
If the government were to go around doing like an IQ test, what do you think would be the average IQ, like, or the average being?
I don't know. I don't know. But IQ doesn't determine about
20.
Okay, so 363. So that's gonna be the distance. Take a picture of your work and send it to me via WhatsApp. Again, take a picture of your work and send it to me via WhatsApp. Take a picture of your work and send it to me.
We doing
via
health
WhatsApp.
science after this?
I even forget about health science. That's true, we are. Okay, so
Oh, no, we could do general science first for a change.
no. All right, so all right, let's move on to this. Okay, so I think we understand how to do this. Let me give
Yes,
you
sir.
all. You do understand it. Y'all understand how to do this, right? In general?
Yes, sir. It's easy as pie.
Yes, sir.
Okay, good. So what I want you to do is let's do grade exercise number 2. Again, let's do grade exercise number 2. I'm gonna put it on the screen for you and we can do this. Go ahead, what's his name? Durante Smith, read number 1. Durante.
Yes, sir. An Olympic runner travels with an average speed of 9 miles per hour and completes the run in 2 hours. Determine the distance traveled.
Ethan Adderley, read number 2. Ethan Adderley, read number 2.
A boat sailed with an average speed of 72 miles per hour and completes its journey in 3 hours. Calculate the distance traveled.
Very good. Genesis Hana, read number 3.
Henry flies his helicopter with an average speed of 112 kilometers /hours.
No,
He journeyed,
kilometers per hour.
per hour. He journeyed from Brazil to Cuba in 4 hours. Determined the distance traveled.
Very good. Kamika Hepburn, can you hear me? Where's Kamika? Kamika Hepburn. Are you writing this down, Kamika?
Yes, sir.
Matthias Turnquest, can you hear me? Where's Matthias?
I can hear you.
I wasn't hearing you earlier. What was the reason for that?
I had gone somewhere.
You have to speak into the mic. Read question number 1, please.
An Olympic runner.
We can't hear you. You have to speak into the mic, Matthias.
An Olympic runner travels with an average speed of 9 miles per hour and completes the run in 2 hours. Determine the distance traveled.
You understand how to do these questions? Yes or no?
Yes, sir.
Okay, and Lavender, read number 2. Lavender, read number 2.
A boat sails with an average speed of 72 miles per hour and completes its journey in 3 hours. Calculate the distance traveled.
Very good. Courtney McKenzie. Courtney McKenzie, can you hear me? Courtney? Where's Courtney? Toriko? Where's Toriko?
Yes, sir.
Read number 3.
Henry flies with his helicopter with an average speed of 112 kilometers per hour. He journeyed from Brazil to Cuba in 4 hours, determining the distance traveled.
You understand how to do these questions, Toriko?
Yes, sir.
All right. All right, class. What number are we on? What number are we on for this?
Number
Number
two.
2.
3.
Number 3?
Number 3.
Number 3, wow.
I'm finished and I'm sending you my answers in the chat.
Take a picture of your work and send it to me via WhatsApp. This is not answers in the chat. Take a picture of your work and send it to me via WhatsApp. All right. Take a picture of your work and send it to me via WhatsApp. Debria DeVoe, where's Debria DeVoe? Debria DeVoe. Can I from Debria? Deja, where's Deja? Can I from Deja? Dondre Borrows, where's Dondre Borrows? Dondre Borrows. Dondre Borrows, can you hear me? Let me check the chat, see if they're responding in the chat. Aiden Deal. Mark Albury, can you hear me?
Yes, sir.
You understand how to do these questions?
Yes, sir.
Okay. What number you on?
2.
Number 2. So you already finished with number 1? Have you answered number 1, Mark?
No, sir.
So you have the answer number 1. Do not just write down the question. Write down the question, answer it. Write down the question, answer it. All right. That's what I need y'all to do. Kavane Seymour. Kavane Seymour.
Yes, sir.
What number you on?
Number 2.
Number 2. You understand what you're doing?
Yes, sir.
Good. Makai, what number you on? Makai, what number you on?
I'm on number 3.
Number 3. And Rashid Wilson, where's Rashid Wilson?
Yes, sir.
What number you on?
Number 2.
Good. Is there anyone who is finished with number 1? If you're finished with number 1, let me know, please.
I'm
Finish with number
I
1.
am.
Finish with number 1.
Yes, sir.
Done.
I am.
Okay.
Affirmative.
Good. Debria DeVoe, what number you on? Debria DeVoe.
I'm finished with all.
Finish it all. Take a picture of your work and send it to me via WhatsApp. For those of you who are finished, take a picture of your work and send it to me via WhatsApp. Who else is finished besides Debria DeVoe?
I am.
That was
Alea?
Empress,
I am
not
as well.
Okay.
Mr.
Good.
T.
Yes.
That was me talking.
That was you?
Yes, sir.
You said you was finished?
Yes, sir.
Oh, okay. Where's Debria? Debria DeVoe. Debria, can you hear me? I can't really hear from Debria.
Most of it, can I be excused for like 10 minutes, please?
Yes, you can. Danaj Moss.
Yes, sir.
What number you on?
Number 3.
Okay. Janaya White. Where's Janaya White?
I'm here.
What number you on?
Number 3.
Number 3. Okay. Do you understand what you're doing?
Yeah, so
Okay. Good. Go ahead.
Mr. Creative, I send you a screenshot. I was trying to unmute, but it wasn't letting me unmute.
It wasn't letting you unmute? Okay. All right. All right. Jemiah Miller, what number you on? Best Jemiah Miller.
Yes, sir.
What number you on?
I finished number 3 now.
Finish at number 3. Who else is finished with all 3 already? Let me know if y'all finished. Who else is finished? Let me know if you.
Yes,
I'm
we're
finished.
I'm finished.
Finish.
Okay.
I am.
All right, good. Okay, so for this one, let's do number 1 together. Any volunteers for number 1? Any volunteers for number
Me,
1?
Mr. Petit.
Go ahead, Genesis.
Number 1.
Pardon?
And
No, Genesis Sweeting.
sorry. Number 1. An Olympic runner travels with an average speed of 9 miles per hour and completes the run in 2 hours. Determine the distance traveled. So you put distance equals speed multiplied by time equals 9 miles per hour, m/h times 2 hours
Times 2 hours.
equals 18 miles.
18 miles. Notice I have MPH. So it's gonna be 18 what? 18. Just
Miles
18
per hour.
No, we just find the distance. It's gonna be 18 what?
Miles.
18 miles. Yes. How many persons got 18 miles? Let me know if you got 18 miles, please.
I did.
I
did.
All right. Anyone else besides Alora and the company who
I
got?
did as well.
I did.
Okay. All right.
I did.
Very good. 18 miles is correct. So all we gotta do is multiply the speed times the time. Simple enough. All right. Any volunteers for number 2?
Me.
Volunteers for number 2.
I will do number 3.
Go ahead, Empress.
Okay. 72.
Read the
72
question. Read the question. Read the question.
Oh, right. A boat sailed with an average speed of 72 miles per hour and completes its journey in 3 hours. Calculate the distance traveled.
Very good. So the distance is gonna be what?
Distance equals speed times time.
Very good.
So I did it over again. And then I'll do 72 miles per hour times 3 hours, which will give me 216 miles.
72 miles per hour multiplied by what?
3 hours.
3 hours. So we have 3 times 72. What is 3 times 72? That's gonna be what?
216.
216. I got 216. What do you get, Empress?
I get 216 as well. Miles.
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 Yeah, miles.
I saying it wrong?
No, I'm not correcting you. Miles. Very good. Anyone else got 216.
Yes.
Miles.
I
Anyone
did,
else got
sir.
one?
Yes, sir.
That's only sound like few persons. The rest of you, how have you also got it?
Yeah, so
Yeah,
Yes, sir.
yes, sir.
I'm still writing down notes. I get the numbers right, but I didn't know what to put at the end because in the question it already had miles in it, so I didn't know if I'm supposed to put a bar.
You asking for distance. So if they ask you for distance, you already know that it's in miles, so it have to be in miles. Okay. Go ahead, Alora. Read number 3.
Henry files his helicopter with an average speed of 112 kilometers per hour. He journeyed from Brazil to Cuba in 4 hours. Determine the distance traveled.
So we need to figure out the distance travel. What's the distance gonna be?
112 miles per hour times 4 hours.
We could do
And the
100.
answer is
100 112. What?
miles per hour
Miles per hour.
times 4 hours
Multiplied by 4 hours.
equals 448.
Divided by 4 hours.
448 miles.
That's gonna give us. When I multiply 112 times 4, I get 448. Is that what you got?
Yes, sir.
448. Did anyone else? What is the units behind it?
Miles.
Kilometers.
Kilometers.
What's the units?
112
What's the units?
Wait.
What's the units? No one knows? What is the units?
Kilometers per hour.
I'm sorry, and you write it wrong. It's kilometers. You have miles per hour.
Miles per hour or kilometers per
You
hour?
have distance equal 112 miles per hour.
Is it?
Multiplied by 4 hours. It's supposed to be kilometers.
Very good. It's gonna be what? Kilometers per hour. 112 times 4 is gonna be what?
448 kilometers.
448 kilometers. Very good. How many persons got it right? 448.
I did.
I did.
Yes, well.
I didn't get it because I get the wrong units.
You put the wrong units. 3 to 3. 3 to 3. Anyone? 3 to 3.
3 out of 3.
3 out of 3 out of 3.
3
2
to
out
3.
of 3.
3 to 3. 3 to 3. It's gonna be 100. Any 2 out of 3 people? Any 2 out of 3?
I got 2 out of 3.
I got 2.
Because I
I
didn't
got
get
2
3.
out of 3.
Me, because I still writing.
Okay.
I got 3 out of 3.
3 to 3. Very good.
1 out of
Excellent.
3.
Well, 1 out of 3. Well, we don't want to make that public. All right. It's got a lot of work to do. Gotta bump up that IQ. All right. So, okay, take a picture of your work and send it to me via WhatsApp. Do that for me right now. Take a picture of your work and send it to me via WhatsApp. Again, take a picture of your work and send it to me via WhatsApp. So we already know how to do the speed. Speed is distance over time. We already know how to do the distances. Speed times time. Now we're gonna figure out how to do the time taken. How to figure out the time taken. So calculate the time taken. Someone mic is open. I don't know.
We
who
don't
the-
pick you up?
Someone mic is open.
My ass hurting from this head.
I don't know. Joel. Joel. I don't even know.
Saying I doing work.
1 second. Someone's mic is open.
You're gonna hear my class talking.
Someone mic is open. And I don't know what that is. And because your internet is laggy, I can't unmute you. I can't mute you. All right, I guess they muted themselves. Because if you didn't, that would have been a juicy conversation. All right, so let's do one more. We have to figure out how to do what time.
Why you have to say to mute them, Mike?
Yeah, we had to say mute them, Mike. Yeah, we had to save them, give them saving grace. All right. So let's go ahead and we're done with this. Okay, so
You could just put a Bahamas Airline ad in front of that.
I know, right? Bahamas Airlines ad, right? The ad coming soon. Okay, good. Okay, so now we need time, right? So so examples. So now number one, it takes, sorry, Jimmy is a pilot. He traveled for time is okay. He travels for 125 miles. Wait, the formula is, let me make sure that's right. The formula is distance over speed. I got you, okay. So he travels for 125 miles with an average speed of 5 miles per hour. Calculate the time traveled. So this one is not difficult. I don't think we need a lot of examples for this. So Jimmy is a pilot. He traveled for 125 miles with an average speed of 5 miles per hour. Calculate the time traveled. So the time travel, what is the formula for time traveled? That's gonna be what? Time travel, what's the formula?
Distance divided by speed.
Very good, distance divided by speed. So time travel, so time is gonna be equal to the distance divided by the speed. And what triangle helps us with that? The same triangle, the speed, distance, and time triangle. If we recall that by using this triangle, we were able to know that if we have speed, right, then the speed is going to be equal to distance divided by time. So therefore, if we have time is going to be distance divided by speed. And this one is very easy because they give us all the information that we need to know. They're all drawings. So for this one, we have that the time is going to be equal to distance over speed. So what is the time? The time is what? So what is the
125 miles per hour.
So we do one. We have 125 miles.
No, the time is 125 miles and the speed is 5 miles per hour.
Very good. The distance is 125 miles and the time is 5 miles per hour. So what we have to do here, we have to divide, right? So we have to say how many times does 5 go into 125 without leaving a remainder? So we say 5 into 125. How many times does 5 go into 12? 5 go into 12, what?
2 times.
Twice, yeah. 5 times 2 is what?
10.
10, very good. And 12 minus 10 is?
2.
2. Bring down the?
5.
Bring down the 5.
5
How
times.
many times does 5 go into 25?
5 times.
5 times, very good. 5 times 5 is what?
25.
25, very good. 5 minus 5 is going to be what?
0.
0. 2 minus 2 is going to be what?
0.
0, very good. So what does that mean? That means that the time travel is going to be what?
25 miles per hour.
Wow.
Very good. 25 miles per hour. 25 miles per hour. All right. Any questions on that? Or y'all understand how we got it? Let me know, please.
Yes, sir. I was wondering why the time is still in the unit per hour,
Oh,
miles per hour.
it's time is going to be 25 hours, right?
Yes, sir.
Yeah, 25 hours. That's a good point. So we canceled the miles and miles. We just left with hour. So let's do another one. This should be. Number 2.
I thought we were calculating the miles per hour.
No, we're trying to figure out the time, right? It says time, it's different. Yeah, time is going to be in hours, okay? You understand?
Yes, sir.
Yeah. Okay. I need a name. I don't know the name.
Makai.
Alice.
Robert.
Bill.
Ohio.
Alice.
Alice. Let's go with Alice. I like Alice. Alice. Alice sounds so. Give me a name.
Jermaine.
Jermaine. Yeah, Jermaine. Jermaine.
Coakley.
Say Coakley.
Moxie.
Jermaine wants to visit. Where you want to go?
Atlantis.
France.
Cool.
France.
France.
Yeah.
To France. Okay, to France. For a what? Vacation?
Enchanté.
Okay. The plane. The distance from the Bahamas to France is how much? What's the distance? Let's say 2 plus 4 plus 8. 2 plus 4 plus 9. Yeah, 249 what? Kilometers. Okay. That's not true, but you know, it takes the plane 3 hours to reach to France. Wait, no, shouldn't give that away. The speed, sorry, the plane travels at let's say it travels at
5. No, I lied. Never mind.
let's say it travels at 83. I don't want it to be difficult, but 83 miles per hour. Calculate the time traveled. Okay, so for this one, we're gonna do the distance. The distance is, well, the time formula is going to be what? Distance divided by speed. right? So go ahead, Ariana. Ariana, can you read the question for me, please? Jermaine.
Yes, sir. Jermaine wants to visit to France for a vacation. The distance from the Bahamas to France, 249 kilometers. The plane travels at 83 miles per hour. Calculate the time travel.
There's a problem. Is, and it's supposed to be kilometers per hour. Because, we have to keep it the same thing. So what's the distance? Class, what is the distance?
249 kilometers.
249 kilometers. What is the speed?
The speed is 83 kilometers per hour.
Very good, 83 kilometers per hour. And the time, the distance is 249 kilometers. What's gonna be the time taken? What y'all got for that one? When we divide 249 by 83.
3.
What y'all got?
3.
Yeah.
3 hours. So how do we do that? We could say 83, right? Into what? 249. And 83 times 3 is exactly 249. And the way you know it is 3 is you could check. You could do 83 times 1, which is 83. That's not gonna work. 83 times 2 is 166. That's not gonna work. And then 83 times 3 is exactly 249. So the answer here is going to be what? 3 hours. Three hours. That's what time taken is, 3 hours. Okay, go ahead, Alex Xavier. Where's Alex Xavier?
I'm doing something right now.
What do you mean you're doing something?
I'm moving rooms.
You're moving rugs?
Rooms.
Rooms, okay. What's his name? Ethan Anelis. That's Ethan. Ethan, can you hear me? Are you unable to speak? I don't know if your mic is working. Okay, go ahead, Ethan, read the question.
Jermaine wants to visit France for vacation. The distance from the Bahamas to France is 239 kilometers. The plane travels at 80 kilometers per hour. Calculate the time travel.
Okay, explain how we got our answer.
We use the formula time equals distance over speed. And then we use 249 divided by 83 kilometers. And 249 divided by 83. And we got 3.
Very good. Thank you, Ethan. Jasmine Rose, read the question and explain how we got our answer.
Jermaine wants to visit to France for a vacation. The distance from the Bahamas to France is 249 kilometers. The plane travels at 83 kilometers per hour. Calculate the time travel.
Very good. So how are we gonna answer it?
We have to divide the distance by the speed, which is 249 kilometers by 83 kilometers, which is equals to 3 hours.
Very good. So how do we get the 3 hours? What did we do with the 249 and the 83?
We divide them.
We divide them. Very good. All right. Janae Williams. Where's Janae Williams? Janae Williams, can you hear me? Where's Janae? What I want you, have you all finished writing this down? Let me know if you all finished writing this down, please.
Yes, sir.
Almost.
Okay. If you have finished writing this down, take a picture of it and send it to me via WhatsApp. Again, if you have written this down, take a picture of it and send it to me via WhatsApp. Again, if you finish writing this down, take a picture of it and send it to me via WhatsApp. Okay. All right, so are y'all done with that? Let me know if y'all done with that, please.
Yes, sir.
Are we good? Are we done with it? Okay, so, okay. Now the final question, great exercise. We're gonna do this one. Great exercise number 3. I want everyone to try this one. It's a nice one. Nice, good question. So we have a lizard runs from a rock to a far shrub with an average speed of 8 miles per hour. The distance from the rock to the shrub is 16 miles. Determine the time taken. Okay, for this one, because of the interest of time, you do not have to write this down in your book. All you need to do is put your answer inside the chat for me. So I just need you to put the answer in the chat for me for this question. Make sure your answer is correct. Go ahead, Sashanique, read this question, please.
The lizard runs from a rock to a far shrub with an average speed of 8 miles per hour. The distance from the shrub is 60 miles. Determine the time taken.
Very good. We need to determine the time taken. Put your answer inside the chat for me, please. Again, put your answer inside the chat. Malik, read the question for me, please. Again, Malik, read the question for me.
Yes, sir. This pressure. All right. A lizard runs from a rock to a far shrub with an average speed of 8 miles per hour. The distance from the rock to the shrub is 16 miles. Determine the time taken.
Very good. And Trinasia, read this question for me, please. Trinasia.
A lizard runs from a rock to a far shrub with an average speed of 8 miles per hour. The distance from the rock to the shrub is 16 miles. Determine the time taken.
Very good. What I want y'all to do is put your answer inside the chat. Put your answer inside the chat for this question. Put your answer
inside the chat.
Put your answer inside the chat for me. I only see a few persons answering that inside the chat. Trayvon Monka, where's Trayvon?
Yes, sir.
Have you taken a picture of your work and
Excuse me,
sent it to me?
Did you call me? Yes, sir.
You send it. Whose phone are you using?
Mine.
You're using your phone? Put your name when you send it because I don't know your number. So put your name when you send it. You understand me?
Did you call my name?
Okay. No, I mean Trayvon Monka. Skylar Hall, where's Skylar? Skylar Hall. Skylar, can you hear me? The rest of you take it. The rest of you take a picture with the rest of you take.
London and Exuma, not NASA.
Ethan Smith.
Hell. So
Read the question for me.
a lizard runs from a rock to a far shrub with an average speed of 8 miles per hour. This distance from the rock to the shrub is 16 miles. Determine the time taken.
Very good. The rest of you, please answer this inside the chat, please. Answer inside the chat. Tell me what your answer is for this.
But do we write this down?
No, don't write it down. Just put answer inside the chat for me. Dior Smith, where's Dior Smith? Can you
Yes, sir.
read the question for me?
A lizard runs from a rock to a forest shrub with an average speed of 8 miles per hour. The distance from the rock to the shrub is 16 miles. Determine the time taken.
Very good. Do you know how to do this, Dior?
Yes, sir.
Okay, so help us. So if we have our formula, right? So our formula says that we have, in order for us to figure out the time, right? So we have this, we have speed, we have, I look like a money sign. We have speed, right? We have speed, we have distance, we have time. If we want to figure out the time, right? What is the formula for time, Dior?
Distance times time.
No, the formula for time. What is the formula for time? Distance divided by what? Dior, what's the formula for time? Distance divided by what? There's Dior. Dior, can you hear me?
Time.
No, the formula for time. The formula for time is distance divided by what? Start with S.
Speed.
Speed. Distance divided by speed. Good. What is the distance?
The
What is
distance 16 miles.
the distance is what?
16 miles.
16 miles. Very good. What is the speed?
8 miles per hour.
8 miles per hour.
8 miles per hour. I need Dior to answer this. Dior, what is 16 divided by 8?
2.
Dior.
10.
No, what is 16 divided by class? What is 16 divided by 8?
2.
2.
2. Very good. 2. Dior, what is 16 divided by 8?
2.
Dior, what is 16 divided by 8?
2.
Very good. So that means that how long did it take for this lizard to reach to the shrub? How long did it take? Class, how long did it take?
2 hours.
2 hours. Very good. Now I got 2 hours. Anyone got 2 hours before me? Let me know if y'all got.
I did.
Anyone got 2 hours before me?
Yes, sir.
I got 2 hours.
2 hours. All right, excellent. All right. Do we prefer average speed or we prefer scientific notation? Which one?
Average speed.
Average speed. Do you prefer average speed
This one.
or time questions?
This one.
Time question.
Time question.
I
Really?
like this one.
Really?
Average speed.
Okay, average speed. Do we prefer average speed or higher purchase?
Average speed.
Average speed.
Average speed.
Average speed.
Average
right.
speed solo.
All right. What I need you to do is take a picture of your work and send it to me via WhatsApp. Again, take a picture of your work and send it to me via WhatsApp.
already did.
Have you already done that? We're going to move on to health science. Again, we're going to move on to health science. Again, we're going to move on to health science. If you're not doing health or general science, we're going to move on to health and general science. If you're not doing health or general science, you can
Good
leave.
night.
But if you are, please stay back. So health and general science people, we
Good
have
night.
to stay back.
Good night.
Again,
Thank you so much.
Good night.
good night. Again, if you're doing health science and general science, you stay back. All right, those who are doing health science and general science, we have to stay back. Okay. All right, so let's move on to health science and general science. All right, my name is Mr. Petit. Today is Tuesday the 18th of February, 2025. The subject is, of course, health science. The last time we were here, what we doing? Anyone remember the last topic we did?
Metonymy and allusion.
No, in health science.
Hey, my lord.
Wow, ouch.
Work done on power.
Say it again.
Work done on power.
You're very low. But in health science, not general science, health science. Come on, health science people.
The blood.
The blood, very good. We said that the blood is a fluid or is a tissue, right? We said that blood is made up of different components. What are the components of blood?
Plasma.
Red blood cells, white blood cells,
Very good.
plasma,
Yes,
and platelets.
yes, platelets. Today we're going to be looking at the human heart. All right. In particular, I'm hoping that we can look at I'm hoping that we can
Finally, something I actually learned before.
I'm hoping that we can get to the passage of blood in the human heart. I'm hoping that we can get that. Now, if you look at it's interesting, right? It wasn't Valentine's Day just like a few days ago, right? So if you look at the different we look at the different images representing a heart, especially in the, what should I say, in the world of Valentine's, you would think that the heart looks like the picture on the left hand, on the right hand side, my right, your left. You would think it looked like this, right? But the heart doesn't look like this. Now, you may think, maybe when you were smaller, you thought that the heart actually looked like this. Anyone ever thought that the heart actually looked like this before?
Yes, sir.
When I was smaller, yes,
Yeah. Yeah.
When I was younger.
Yeah, when you're younger, right? So you think that, wow, the heart looks just because, sign of the heart, stuff like that. But the heart actually looks like this, right? All right, with all type tubes and blood vessels in and out. We could divide this heart into how many pieces? Into how many pieces?
4.
Into 4 pieces, right? The 4 pieces, okay, let me do this properly. The 4 pieces of the heart are going to be, let me go ahead and do this with, let's say, block. So we could divide the heart into 4 pieces. What do we call the 4 parts or the 4 divisions? We call them.
Right ventricle.
We call them chambers, right? So the heart can be separated into 4 chambers, right? You have the right atrium, right? So you have the atrium, right? Atrium is one on top. You have the ventricle. This is going to be the right ventricle. So right ventricle, right atrium, right? This one is the right ventricle, right? Right ventricle. I'm not gonna write the full thing. This one is gonna be the what? The left atrium, right? And this one's gonna be what? The left what? Ventricle. Okay, so this is the divisions of the heart. Okay, This right here is what we call the aorta. This is the biggest blood vessel, so the biggest artery, right? We know the arteries carries blood away from the heart. Then we also have these stuff. This is the vena cava. The vena cava they are the largest vein, right? In particular, the inferior vena cava is the largest vein, and this one right here is the superior vena cava, right? Superior vena cava. Okay. So the purpose of the heart is to what? The main purpose of the heart.
Pump blood to the body.
To help to pump blood, right? And the strongest part of the heart is going to be right here, which has a lot of blood vessels. That's going to have a lot of muscular to it, so you'll be able to pump the blood from the heart to all of the rest of the body. All right, away from the heart. So that's that diagram. Let's go ahead and formally write this properly. Spiral drawings. Let's put this right down. Let's talk about the heart. So the human heart is the pump that drives the circulatory system. So what system is the heart part of?
The circulatory system.
The circulatory system.
Circulatory.
Very good. I'm not only talking to 3 persons, so let's try this again. Which system is the heart part of? The system.
The circulatory system.
The circulatory system, right? And the purpose of the heart is to pump blood, right? Very good. The purpose of the heart is to pump blood. The heart is made up of what? Right? The heart is made up of what?
4 muscles.
Say it again. Muscles?
Tissues.
4 muscles.
Muscles, tissues. What? What do you think? What is the heart made up of? Muscles, tissues, cells, what?
Cardiac muscles.
Say it again.
Cardiac muscles.
Someone said it. Say it again.
Cardiac muscle.
Very good. The heart is made of cardiac muscles, right? These are special types of muscles because they are involuntary, which means they move without our conscious control.
Isn't that what the spinal cord is for? That piece that's connected to the back of the brain?
No, the spinal cord doesn't. No, we don't control the movement of the heart, you know. The heart moves involuntarily. So even if I asked you, hey, I say, okay, Cleveland, raise your right hand. You could raise your right hand, right? You could, right?
Yes, sir.
If I say blink twice, you could blink twice, right?
Yes, sir.
If I say stop your heart from beating, how can you do that?
By not breathing at all.
Well, go ahead and stop breathing. Is your heart gonna stop? Is your heart gonna stop even if you stop breathing?
No, sir.
Can someone help him? Is the heart going to stop beating?
Way,
Is
no,
the heart
sir.
going to
The
stop
only way
beating?
is if you die.
The only way is if you what?
Die or
Die.
yuck it out.
If you die, right? So, yeah. So the heart moves without our conscious control. You understand that, Cleveland?
Yes, sir.
Did you try it?
I only lasted like 20 seconds.
Did you try? Did you check your heart pumping? You did check it? You still felt your heart pumping, right?
It didn't stop.
It didn't stop, exactly, right?
You could slow it down.
Yeah, but you can't stop it unless you Yeah, unless you die. The heart, a heart has 4 what? Divisions, which we call what? Chambers.
Chamber.
The left and right atrium are the upper chambers, and the left and right ventricles are the lower chambers. Okay. All right. How many chambers does the heart have? Class? How many
4.
Four
Four
chambers.
altogether. What do we call the upper chambers?
The left and right atrium.
Left and very good. Left and right atrium. What do we call the lower chambers?
The left and right.
Left and right ventricle.
Left and right ventricles. Very good. Left and right ventricles. Okay. Now, let's talk about blood flow, right? So blood, when the blood enters the heart via the vena cava, right? Via the inferior vena cava, which is the largest vein, or the superior vena cava, which is just a big vein. How would we describe this blood when it enters the heart? How would we describe the blood when it enters?
Deoxygenated.
It what? Deoxygenated. Let me read this again. When the blood enters the heart via the inferior. What are you talking about, Tasha?
The part that says the heart.
Okay. Means they move without our control. Thank you. When the blood enters the heart via the inferior vena cava, the largest vein of the blood, this blood is what? Deoxygenated.
And it's turned into oxygenated blood.
Yes, deoxygenated. What does it mean when I say deoxygenated?
It lacks oxygen.
Very good. It lacks oxygen. Lacks oxygen. Right? But blood that leaves the heart, that will eventually leave the heart from the left ventricle is oxygenated blood. What do you mean by oxygenated blood?
There's a high level of oxygen.
Very good. Blood has high level of oxygen. Okay, so keywords here. We have ventricles, right? Ventricles. We have, let me highlight this green. We have ventricles. We have atrium. We have inferior vena cava. The keyword right now, inferior vena cava. and then superior vena cava. Then you have deoxygenated. Let me underline that. And then we have oxygenated blood. All right, go ahead. Go ahead, Jada, read this paragraph that we have so far. Jada, can you read the paragraph that we have?
Yes, sir. The human heart is the pump that drives the circulatory system. The purpose of the heart is to pump blood. The heart is made of cardiac muscles. These are special types of muscles because they are involuntary muscles. This means they move without our control. The heart has 4 chambers. The left and right atrium are the upper chambers, and the left and right ventricles are the lower chambers. When the blood enters the heart via the inferior vena cava, largest vein, or the superior vena cava, a very big vein, this blood is deoxygenated blood, which means lacks oxygen. But blood that will eventually leave the heart from the left ventricle is oxygenated blood, has high levels of oxygen.
Very good. So the pathway of the blood, or the blood flow pathway, right? So let's talk about that. By the way, what is the largest vein?
The inferior vena cava.
Very good. Very good. And what type of blood enters the inferior vena cava? How do you describe this blood that enters the inferior vena cava?
It is the
Deoxygenated. So blood that enters the heart is what?
deoxygenated.
Deoxygenated. And blood that leaves the heart is what?
Oxygenated.
Oxygenated. Okay. So here is the pathway of blood. So here is the pathway of blood in the heart. Step 1, blood enters the heart via the inferior. So let's say not blood, let's describe it, deoxygenated blood. Deoxygenated blood enters the heart from the body via the inferior and superior vena cava. Blood enters the right atrium. Blood enters the right ventricle. Blood is pushed to the, so once the blood enters the right ventricle, it wants to go to which organ? Because it needs oxygen. It wants to go to which organ?
The lung.
It wants to go to the lungs. So blood is pushed to the lungs and passes through. There's a specific artery that it passed through in order for it to
Aorta?
not the aorta, no. No, not the aorta.
Pulmonary vein.
Pulmonary.
Vein.
Why you say pulmonary vein?
Pulmonary artery.
Artery.
No, she's right. She's right. It is pulmonary vein. I don't know why. The pulmonary vein carries oxygenated blood. Wait. I'm asking, Jasmine, I'm saying from the right ventricle to the heart. From the right ventricle to the heart. What would that be? That would be the
Artery.
pulmonary artery, yes. Right? So the pulmonary passes through the pulmonary artery. So the pulmonary artery is going to be the only artery that carries the oxygenated blood. Okay? So blood is pushed to the lungs and passes through the pulmonary artery. Number 4, at the lungs, so blood gets oxygen at the lungs, right? And then after the lungs, what happens? And goes to what? Blood goes
Left ventricle.
to, not the left ventricle, to the right what? Atrium, and passes. Okay, let me say pause, via, right? Via the pulmonary artery. Let me make sure that you understand that in order for it to get to the lungs, it must pass through the pulmonary artery. So blood goes to the right atrium via the pulmonary vein. So it must go to the pulmonary vein before it goes to the right atrium. So blood goes to the right atrium via the pulmonary vein. Next, blood enters the the left ventricle, right? And then this oxygenated blood is pushed to the rest of the body. Via the aorta. Okay, that's basically the pathway. So let me see if I could describe the pathway for you in a nutshell quickly, so for y'all to understand. Let's use this diagram. It's a nice diagram we have here. So let me put this on this side. So y'all can get it. Okay, so I put this on this side, good. And then put this on this side. So we got enough space. Maybe I could put this there. Okay, what I can do, I'm gonna move the date so y'all could still be able to see it properly. Remove the date and all this stuff. Okay, good. All right, so let's look at our diagram. So first things first, blood. So this is the inferior vena cava, right? Let me go ahead and erase all this. So this right here is the inferior vena cava, right? So the inferior vena cava is the largest vein. So blood is coming from, this is deoxygenated blood, right? Coming from the body, and it's gonna enter where? Which atrium? It's gonna enter which atrium? The right atrium. Very good. So this is where it enters here. So blood enters the right atrium. Okay, I'm not talking to myself. So where does blood from the inferior vena cava enter? Where does it enter?
Through the right atrium.
It enters the right atrium. Some persons are still not answering. Let's try this again. Where does blood from the inferior vena cava and superior vena cava enter?
Through the right
The
atrium.
right atrium.
The right atrium. Very good.
Atrium.
After it goes to the right atrium, it passes these valves and enters to the right ventricle. Okay. So from the right atrium, it goes to the right ventricle. Now, the blood, how would you describe this blood? Is it oxygenated or deoxygenated? This blood that enters from the body.
Deoxygenated.
Deoxygenated. It lacks blood, right?
Deoxygenated.
Yeah, so it needs what? What does it need?
Oxygen.
It needs oxygen. It needs oxygen. Very good. So since it needs oxygen, it's gonna go to the through the pulmonary vein, and it's trying to go to the heart. I mean to the lungs, right? Trying to go to the lungs. What did it need from the lungs? Or what is it gonna get from the lungs?
Oxygen.
Oxygen.
It's gonna get oxygen. Very good. Breathe in, stuff like that, get that from the air. Then it's gonna come back from the pulmonary vein. It's gonna go to the lungs, and then after that, it's gonna go through the pulmonary artery. So it passes through the pulmonary artery, and then it goes back into the pulmonary vein. After it goes in the pulmonary vein, it enters inside the left
ventricle.
No, left atrium first. Left atrium first. Then after it goes to the left atrium, it goes passes through this little valve, and it goes to the what? The left what?
Left ventricle.
The left ventricle. Very good. Know that the left ventricle has strong muscles, and it's gonna push this blood to the aorta and through the rest of the entire body. So this right here, that's why it has to be strong. It's gonna push that blood all the way from the heart to the rest of the body. And that's the pathway. Okay. So what's the pathway? Inferior, superior vena cava, right atrium, left ventricle, pulmonary artery, lungs, pulmonary vein, left ventricle, left atrium, left ventricle, aorta, the rest of the body. Okay. All right, so.
Excuse me, Mr. Petit, you know of left, you know of right atrium? Yeah.
What I have?
I mean left atrium. It's the left atrium before the left ventricle.
You mean what? In the thing I was saying or what?
What you saying?
Yeah. Inferior and superior vena cava, right atrium, right ventricle, pulmonary vein, lungs, pulmonary artery, lungs, pulmonary vein, left atrium, left ventricle, aorta, to the rest of the body. Okay, and that's how it circulates. All right. So you have to understand how this goes. You have to understand the blood flow pattern, and we have to go over this consistently so that you can really get a handful of it. But at least you get exposed to it. We have to go and review because I don't think all of you understood exactly what I was talking about. But at least this gives you a starting, that's a good overview of what it is, what we have so far. Go ahead, Jerusalem. Where's Jerusalem? Jerusalem, can you hear me? Can I from Jerusalem? Kevin Wallace, can you hear me?
Yes, sir.
How many chambers does the heart have?
What?
How many chambers does the heart have? Class, can y'all help him? How many chambers does the heart have?
4 chambers.
4.
Oh, very good. So Kevin, how many chambers does the heart have?
4.
4 chambers. Class, what are the 4 chambers? What are the
Left and right atrium.
Left and right ventricle.
Left and right.
ventricles.
The left and right atrium and the left and right ventricle. Okay. What do we mean by deoxygenated blood?
It lacks oxygen.
It lacks oxygen. What do we mean by oxygenated blood?
That has
High level.
it has a heavy level.
Has high oxygen levels.
Very good. That's high oxygen levels. Very good. All right. So what is the largest vein?
Inferior vena cava.
Inferior vena cava.
Yes.
Good. All right. So are y'all done with the notes? Let me know, please, so I can move on.
Yes, sir.
Are y'all done with the notes? Let me know,
No,
please.
sir.
Oh, so I'm gonna take a screenshot.
Take a screenshot because we have to move on to general science, and the people who are doing general science need their notes as well. So take a screenshot if you don't have this written down already. Let's go ahead and do this. So we have to go on to general science. Again, we have to move on to general science. Okay. Are y'all done with this slide? Let me know, please, before I move on to the next slide. Are y'all done with this slide?
Yes, sir.
Yes.
Yes, sir.
Okay. I was in unison. So the rest of you who are not finished with the slide, please make sure take a screenshot of this so that you could be able to take advantage of the material that we have. We talk about the last time we were here in general science. What were we talking about? Anyone can remember the last time we were here in general science?
Friction.
Not friction, no, not friction. Talking about what?
Power
That's
and
how
work.
the work.
Power and work, right? We said that, let's go with this, right? The formulas for those persons who were not here. We said that work is going to be equal to what? It's the formula for work. Force multiplied by what?
Times distance.
Multiplied by distance, right? That's the formula for work. So work is only done when the force, when the object moves in the direction of the force. Okay. And you have power. By the way, work is measured in what? How do you measure work?
Joules.
In Newton meters, which is also joules, right? It's joules, but joules is Newton meters, right? And then we have power. What is power? Power is the what? Is the rate.
The measure.
Is the rate or the amount of or the rate at which work is done. That's basically what it is. So it's gonna be work divided by what? Divided by time. And the formula for power is what?
Work joules divided by time.
Joules over time, joules over second, which is what? It's gonna be what? Watts. Right, watts.
Work done.
Right. So that's what we did last week. We did power, we did work done. So now today we're gonna be looking at basically I'd say forces and machines. So you know that there are not only one type of forces on the planet. There are multiple forces, many forces acting on us. We're going to be looking at the forces and we're going to be looking at the machines. So today is, my name is Mr. Petit. Today is Monday, Tuesday, Wednesday, Tuesday. Today is Tuesday the 18th of January, February 2025. The subject is, of course, mathematics? No, general science. Today we're going to be looking at the topic is forces and machines. Forces and machines. Forces and machines. Forces and machines. Okay. What is a force? What is a force?
A push or pull of an object.
Who said that?
Jada.
Jada, very good. A force is a push or pull. Okay. That's what we mean by a force. When we say a force, that's when we have a push or a pull. So let's write that down. Right. A force, loosely speaking, is basically a push or pull. Right. So a force is a push or pull. It makes things move, right? So forces makes things move. It makes things move. Or stop moving, or change direction. So a force is a push or pull. It makes things move or stop moving or change direction. Force is measured in newtons, so it is measured. It's measured in newtons, right? And we use a capital N there. So let's talk about the types of forces that we have, right?
Magnetic force.
Magnetic force. So there are various forces such as what? Do you know that we have frictional forces? You know the word of friction?
Yes, sir.
Gravitational forces. What is gravity?
What keeps us down on the ground?
Yeah, what keeps us down?
Pulling matter down towards the earth.
Very good. Right.
Is that like for every equal, there's an opposite and equal reaction?
That's another theorem.
Oh.
Gravitational forces. Then we have magnetism, so magnetic forces. So magnetic forces. You also have electrical forces. You also have so we have reaction forces. Reaction forces. Reaction forces would be the same thing with Cleveland talking about, like an equal and opposite reaction, right? So you're right, Cleveland. But they call them reaction forces. And then we have an push and pull contact forces. All right. So that's what we mean. So question, class, how do we define a force? What is a force?
A push or pull.
A push or pull, very good. So the force is a push or pull. What is force measured in?
Newtons.
Newtons, very good. Force is measured in newtons, right? What are some examples of forces that we have?
Frictional, gravitational,
Electrical forces.
Magnetic.
Gravitational.
push
Gravitation.
and pull contact.
Very good.
force.
Push and pull contact forces and so on. All right. How is friction produced? Let's talk about friction, right? How is friction produced?
When two surfaces rub against each other.
Right. So friction is a force. that is produced when two surfaces rub each other, right? When two surfaces rub each other. This force, it goes in the opposite direction, right? So this force opposes the motion of a moving object. Slows it down, and eventually makes it stop. So that's what we need to know about friction. Friction goes in the opposite direction. All right. That's why it's called friction, right? It's like something that you have to overcome, right? If you want to move forward, you have to overcome friction. So friction, and it's true because the force friction itself, it goes in the opposite direction, all right? It opposes the motion of a moving object. So much so to slow it down or even make it stop. There are various. All right, so class, what do we mean by, sorry, when is friction produced, right? When is friction produced, class?
When two surfaces are rubbing against each other.
Very good. Very good. When two surfaces are rubbing against each other. So the force of friction, what does it do? What does it oppose? What does it oppose?
The slowing down of moving objects.
What does it oppose? What does it oppose? So
The motion
the
motion of
motion
moving objects slows
Very
it
good.
down and eventually makes it stop.
Very good. Very good. So when is friction small and when is friction large, right? When is friction small and when is so when can you feel friction the most? When you can feel friction the least?
On rough surfaces.
Very good. So friction is small on what?
Rough surfaces.
Friction is small
on flat surfaces.
for smooth surfaces, right? So if imagine pushing a box across, let's say a glass surface,
A marble.
right? A marble surface, right? It feels smooth, like it just slides and glides. In fact, if there was no friction, if you had a frictionless surface, when you push that object, the object would never stop moving ever, 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 until they encounter another force to stop it, right? Imagine that, right? That's if you had a frictionless surface.
Because even smooth things has like dents in it.
Because even smooth things have some sort of friction, right? Go ahead. Go ahead, someone have a question? So friction is small for smooth surfaces like glass, ice, right? Right? Or a bald tire.
I thought she was going to say a bald guy.
Oh my goodness,
Issues from
no.
So what would
No. Go ahead, Trayvon.
What would two objects colliding be? Gravitational forces?
Two objects colliding?
Yes, sir.
What objects are they? What is they? Like what? Car or what is it?
It could be a cow or it could be like planets or
Planets? 1 second, class. All right. So you're talking about a collision. Talking about a collision, right?
Yes, sir.
Yeah, so like I said, if you had a frictionless surface and you push an object, the object would not stop moving. But because there's some sort of friction, eventually the object stop moving. Now, in space where you have objects just floating and floating around, you could have collisions that happen, right? But here, when we have a surface and you push that object on the surface, if it's something that's smooth like glass or marble tile, like even if you like walking on a marble tile and like you just gliding, it just feels better. Especially with your socks on, right? If you have them smooth church socks, like it's just smooth. You just
I like
glide
do
on
that
it,
every Sunday.
right? Just glide on it, right? And so that's because it doesn't have much friction. And you literally just glide. But friction, right? Where is Trinasia? Trinasia, can you hear me? Trinasia, can you hear me? Where's Trinasia? No, I can't hear from her. Friction is large for rough surfaces. Like what? Like sandpaper.
Like a road.
Concrete.
Sandpaper, concrete.
Rock.
Yeah. Right? And even a match. Anyone ever light a match before?
I have.
Like an actual match.
What about staircase?
Right? So the reason why the match lights is because it encounters what? It encounters friction, and it feels good. Like when you scrape it, it's like, oh wow, that's nice, right? And that causes it to light it, especially because of the chemicals that it have in there. All right. Now, if I want a lower friction, if I want there to be less friction, what must I do? Right?
Lubricate the area
So ways to reduce friction. How can I reduce friction?
by lubricating.
Who said that?
Actually,
Yeah, Sashnik, very good. You sound different though. Maybe you have something like whatever, but you sound different. But you can lubricate, right? That means like anyone ever use WD-40? Right? I don't know if y'all ever heard of WD.
Yes,
Y'all know what is WD-40?
WD-40.
WD-40. Now that actually works. That actually works. That is work. I saw it in real time. Right? We had a squeaking door, and the door was just squeaking. And the reason why it was squeaking was because there was friction. And all the gentleman did was spray some WD-40, and would you believe it? It didn't. The sound stopped. The sound literally stopped. I was like, wow, this thing actually works. This thing is not a scam. So WD-40 helps with that because it reduces the friction, right? So you can reduce friction by lubricating. So lubrication. So placing. That's it. So I'm understand. Placing a slippery substance, which we call a lubricant, on the surface that you want to lubricate. For example, oil. For example, oil or soap. Now, what's another way we can reduce friction besides
We can use like wheels or something.
Who said that?
Michael.
Michael, very good. Using rulers or what? Wheels between surfaces. For example, pulling a piano on the ground is much easier when it has wheels. Anyone ever try to push something and it was so heavy, but when you put wheels on it, like it's easy, it's just smooth, right? That ever happened to y'all?
Yes, sir.
Yes, sir.
Yeah. So if you want to move something heavy, you could put wheels attached. If the wheels are attached to it, it would move way more smoother. And that's because friction has been what? Reduced or what? Or lowered. All right. Friction has been reduced or lowered. Okay.
Excuse me, Mr. Petit.
Uh-huh.
Wheels only work on some surfaces.
Yeah, I mean, of course, it only like these. It depends on what like depends on what machine or what the object you're talking about, right? Yeah. All right, Chai, go ahead and read the paragraph on. Start from a force is a push-up pull.
You said where force is a push or pull?
Yeah, force is a push-up pull, yes.
Right.
We can't open the door. It's too dangerous to open the door. We cannot open it.
So you mean when it says push or pull contact?
Mr. Petit, send our work to you, right?
He said yes.
All right. Friction is a force that is produced when two surfaces rub each other. This friction opposes the motion of a moving object, slow it down, and eventually makes it stop. Friction is small for smooth surface like glass, ice, or a ball tire. Friction is large for rough surfaces like sandpaper, concrete, and matches. Ways to reduce friction: lubrication, placing a slippery substance, lubrication, on the surface that you want to lubricate. For example, oil or soap. Wheels, using rollers or wheels between surfaces. For example, pulling a piano on the ground is much easier when it has a wheel.
I think he's AFK. away from keyboard.
It's basically
We'll
time.
be back
So anyway,
soon. Let's teach the class. So what is Newton's, what is first
Hi,
method?
Kevin A.
Hello? Can you hear me?
We were teaching the class.
Yes.
I noticed that. Take a picture of your work and send it to me via WhatsApp again. Take a picture of your work and send it to me via WhatsApp. I need y'all to do that right now, please. If you are finished with that, then you can leave. All right.
Good night. Good night, Mr. Petit.
Good night, Mr.
Good
Petit.
night.
Good night, Kevin A.
Well, he can't be gone because the thing's still saying recording.